Hello, here's our next 2.3 video. This one is about systems that have zero solutions or infinity solutions. So remember from before that any system of equations always has no solutions. And remember that looks like something like this when you graph it, where you have two lines that have the same slope but different y-intercepts and they never intersect when you graph them. That has no solutions. Or you have one solution where the graphs intersect at one point, like this, or you have an infinite number of solutions, which means that the two equations are really equations for the same line, and all the solutions from one are also solutions of the other one. Now, let's see how we can find what situation it's in when we have the equations and we're not solving it by graphing. How do we know which one of these three situations we're talking about? So let's do this with elimination here. So right now there's a 3x and a negative 6x. Those won't cancel out yet, but if I multiply both sides of the first equation by 2, that will give you a 6x, and then let's multiply the other side by 2 also. That will give us this equation 6x minus 2y equals 8. And then we can do the addition step here, where we add the left sides together and also add the right sides together. That gives you 0x plus 0y equals 10. Or in other words, 0x plus 0y is really just 0 equals 10. Now, that is never true. No matter what x and y are, 0 is not equal to 10. So if this is false, that means that the original system of equations, one or the other, must always be false as well. So that means there's no solution. And that's how you know that if you're going to graph it, you'd have parallel lines like this. And so that's true whenever you get some number equals another number, and there's no variables in it. There's no way to make an equation like that true. Okay, now let's see what happens in a sort of different situation with b here. Maybe you want to try to eliminate the y's, and you see the purple equation has a negative 4y, and this has a negative 2y. So maybe let's take that first equation and multiply both sides of that by negative 2 to make this become a positive 4y. And you might notice what's going to happen when you do that. That's going to give us the equation, I meant to say negative 2 there, but I didn't write it. We got negative 2x. Negative 2 times negative 2y gives you plus 4y equals 3 times negative 2 is negative 6. And then the 2x plus negative 2x, when you add this here, gives you 0x. The negative 4y plus 4y is also 0 times y. So the whole thing comes out to be just 0 equals 6 minus 6 is 0. Now that's different from 0 equals 10. There are no variables in here, so 0 equals 0 is just always true. And when you get a result like that, it's really because the equations were equivalent, and so when you eliminate stuff, everything ends up getting eliminated because you're really just adding an equation to its opposite. And that means the graphs of them are really going to be exactly the same, and so there's an infinite number of solutions.